Using an existing three-phase service for a single-phase load, such as X-ray equipment requiring 208 volts, 120 volts, is generally permissible. The key consideration revolves around ensuring that the overall three-phase system remains balanced, even with the single-phase load connected. When one phase of the three-phase disconnect and fuse arrangement is not utilized for the single-phase equipment, the load in the other two phases will be higher. This is not inherently problematic, but it necessitates careful evaluation to prevent overloading any of the remaining phases. Firstly, calculate the current draw of the single-phase X-ray equipment at both 208 volts and 120 volts. This can be determined using the equipment's power rating in watts and the voltage. The formula for single-phase power is power equals voltage times current, or current equals power divided by voltage. Secondly, determine the existing load on each of the three phases of the three-phase service. This can be done by measuring the current on each phase using an ammeter or by reviewing the load calculations performed during the initial installation. Thirdly, add the calculated current draw of the single-phase X-ray equipment to the current draw of the two phases that will be supplying it. Fourthly, compare the total current draw on each of the two loaded phases to the ampacity of the conductors feeding those phases and the rating of the overcurrent protection devices, such as the Class T fuses and the pull-out disconnect. The conductor ampacity must be sufficient to handle the total current, and the overcurrent protection device rating must not be exceeded. This is typically governed by the National Electrical Code, specifically Article 210 and Article 215, which address branch circuits and feeders, respectively. Conductor ampacity is determined by NEC Table 310.15b16, which provides ampacities for insulated conductors rated up to 2000 volts based on the conductor's insulation type and the ambient temperature. Correction factors may need to be applied if the ambient temperature exceeds 30 degrees Celsius or 86 degrees Fahrenheit, as outlined in NEC Table 310.15b2. Adjustment factors may also be required if multiple current-carrying conductors are bundled together, as specified in NEC Table 310.15b3. Overcurrent protection device ratings must be selected in accordance with NEC Section 240.4, which generally requires that conductors be protected against overcurrent in accordance with their ampacities. The next standard size overcurrent protection device is permitted if the conductor ampacity does not correspond to standard size. However, there are exceptions to this rule, particularly for motor circuits and certain types of equipment. Fifthly, consider the voltage drop. The added single-phase load can cause a voltage drop on the two phases supplying it. Excessive voltage drop can negatively impact the performance of the X-ray equipment and other equipment connected to the same electrical system. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. Voltage drop can be calculated using the formula voltage drop equals 2 times K times I times D divided by circular mils, where K is the direct current constant, which is approximately 12.9 ohms for copper conductors, I is the current in amps, D is the one-way distance of the circuit in feet, and circular mils is the cross-sectional area of the conductor. If the calculated voltage drop exceeds the recommended limits, the conductor size may need to be increased. Sixthly, ensure that the neutral conductor is adequately sized. In a 3-wire, 208 volts, 120 volt single-phase system derived from a 3-phase service, the neutral conductor carries the unbalanced current between the two phases supplying the single-phase load. The neutral conductor must be sized to handle the maximum unbalanced current, which is typically the same as the current draw of the 120 volts portion of the single-phase load. NEC Section 220.61 provides guidance on neutral conductor sizing. Seventhly, verify the grounding of the X-ray equipment and the single-phase panel. Proper grounding is essential for electrical safety and to minimize the risk of electric shock. The equipment grounding conductor should be sized in accordance with NEC Table 250.122, which bases the conductor size on the rating of the overcurrent protection device protecting the circuit. Eighthly, consider the impact on the overall three-phase system. While it is permissible to use a three-phase service for a single-phase load, it is important to strive for balanced loading across all three phases. Unbalanced loading can lead to increased losses, reduced efficiency, and potential problems with rotating equipment connected to the system. If the single-phase load is significant, it may be worthwhile to consider installing a separate single-phase service or redistributing existing loads to improve balance. Ninthly, proper installation is critical. Ensure that all electrical work is performed by qualified personnel in accordance with the NEC and any applicable local codes. Use appropriate wiring methods, connectors, and equipment. Inspect the installation thoroughly to verify that it is safe and compliant. Tenthly, documentation is essential. Keep accurate records of all calculations, measurements, and installation details. This documentation will be helpful for future maintenance, troubleshooting, and modifications. In summary, while it is acceptable to tap a single-phase 208 volts, 120 volts load from a three-phase system by not utilizing one phase, a thorough evaluation of the system's capacity, balance, voltage drop, and grounding is paramount. Following the guidelines outlined in the National Electrical Code and employing sound engineering practices will ensure a safe and reliable installation. Remember that the existing Class T fuses in the pull-out disconnect provide overcurrent protection. Class T fuses are current limiting fuses known for their high interrupting rating, making them suitable for protecting circuits with high available fault currents. When adding the single-phase load, confirm that the existing fuses are appropriately sized to protect the conductors and equipment, taking into account the added load. If the existing fuses are not adequately sized, they must be replaced with fuses of the correct rating. Always consult with a qualified electrical engineer or licensed electrician to ensure compliance with all applicable codes and standards and to ensure the safety and reliability of the electrical system.